Coffee with an Expert is a monthly meeting series, 30 minutes every month to discuss digital manufacturing and smart factories with our GE Vernova experts. Thank you for joining us. Here are scheduled for the year. Feel free to register for the sessions of your interest using the QR code. You can also access the replays of past sessions, like the ones on AI, through this QR code as well. Next. Today, we are meeting to discuss smart factory for the metals industry. Let's welcome our experts. First, Stuart Forrest from our business consultant team. He will be joined by a special guest, Lennart Geissens from Qubris, one of our system integration partners. We will also have the privilege to welcome Pradeep Vasant-Suvarna from Qatar Steel, who will answer questions about his customer experience using Proficy. This is a great opportunity to explore what smart factory can do for the metals industry. So let's strike while the iron is hot. Stuart, over to you.
Okay, so hello. So what we'll be doing today, we'll have a brief introduction to GE Vernova. Then we'll talk about the solutions for metals that are provided by the smart factory solution. Then we'll look at the use case and we'll have a demonstration, followed by some questions with Pradeep and about the success he's had. And then finally, questions from the audience. So I'll begin with a brief introduction to our company. I'll highlight what sets us apart and why metals companies choose to partner with us. Our software is utilised by 1,200 customers in the metals plants worldwide, with over 500,000 installations across various industries. Every day we tackle manufacturing challenges. We empower our customers to achieve more. This is partly thanks to being a manufacturer ourselves and having expertise in software for the last 35 years. This expertise has been consistently recognised by industry analysts like Gartner and IDC. Our commitment to innovation has led us to launch the first complete SaaS MES solution in 2022. GE Vernova fosters a broad ecosystem of partners, aiming to maintain close customer relationships and offer flexible engagement models. We possess expertise and we're deeply invested in technological advancements. By actively listening to our customers, we engage in co-innovation and ultimately deliver superior solutions. So let's talk about our solution in metals. We see a number of challenges regularly when talking to our customers, and I'm going to focus on two of those today. So the first one, regulatory requirements. Particularly in the steel industry, we see that various information has to be collected to generate the final certificates of conformity. Secondly, management of assets. There's various assets such as furnaces, tundish refractory linings, electrode management that need to be considered. So for these, we have some solutions that produce outcomes. So with regard to the regulatory requirements, we have a digital footprint of manufacture. You basically capture all the raw materials that have been used. We capture the energy. We capture the processes that have been undertaken. During those processes, we capture the quality attributes of the product. And then we have this complete data set that represents the manufacturing of the final product. This data can be collated and sent to regulatory bodies to create the final certificates of conformity. With regard to assets, various assets use refractory linings. These may be ladles, these may be rotundish. These need replacing after certain usage. So in some cases, we can monitor the temperature across the tundish to detect when the refractory requires some maintenance. But in a ladle, we might track the usage. We might want to avoid contaminants from different alloying elements in different melts. We may want to manage a number of melts that ladle has used, and so on. So all of this information, when automatically captured, can help to guide production. Another example, not refractory, but electrodes. Again, we can track the electrode consumption in different use cases, in different operational modes, and help to optimize using AI or ML technology the consumption models. Maybe this will be also involve the models to improve energy consumption for that particular process. So all in all, no, we have solutions for most of these or all of these challenges. We don't have time today, of course, to talk about them all. We have some examples of where some of these challenges have been addressed. And of course, today we have Qatar Steel joining us to tell us their story about this. So at this point, I would like to pop over and ask Lennart Gayson from Qubris to give us a demo of a solution that they have implemented. This will cover, in particular, the electric arc furnace area within the process of a DOI-driven continuous casting plant. As you can see, the entire solution is an end-to-end solution, and although we're only seeing today the melt shop, the entire all of the aspects within this diagram can be monitored, managed, and visualized. So over to you, Lennart, if you'd like to take the screen and do your demo.
Thanks. Thank you, Stuart. So, as Stuart said, for this demo, we'll be focusing on the melt shop area of a steel manufacturer using an electric arc furnace, which can consume material that ranges from either 100% scrap to 100% DRI. The melt shop here consists of 3 departments: the electrical furnace, where the majority of the steel is melted, a refining stage, and then a continuous caster producing steel billets. This results into 3 operator cockpits, 1 yard management screen, and a management dashboard. So first off, the electrical furnace department. Usually, most of this information is acquired through a historian and is automatically populated. On the left here, we see some heat details, heat times like power on, power off, the turnaround time, but also the gunning, fettling time and electrode change, because next to the gunning consumption or the fettling consumption, as you can see here, the gunning and fettling also means that there's a downtime. If we here enter the total minutes of work that was required, it is also saved as a downtime. So if we enter here the 10 minutes of gunning that was necessary, 5 minutes of fettling, it means that downtimes are automatically created in plant apps. So in the background, it's fully normal downtime. Next to that, we have the quality defects, which, if selected, which are copied for the refining stage to be visible. Because of this quality defect, the operator, he might want to add some more information for his colleagues at the refining stage. So he can add a comment here. that says new low carbon DRI has been used for batch X, for example. It just adds it. And then in the next stage, it's also visible. Next to that, we have the basket composition, because as we said, we can also add a combination of all different kinds of metals and scrap. So in this example, 31 tons is added into the basket, which 29, and then of that metallic, even 12 tons of scrap. Below, we have the steel analysis, where a sample is taken from the furnace and is being measured. And then here we see the number of heats for a column and pole that they are counted and shown here. If a pole needs to be added here, they can do it. So let's say, for example, this pole of the arc furnace needs to be replaced because it's too long. So they remove the pole from the furnace. They put it onto an empty space, so 2. And then here a new, because this has been fully consumed, they add a new hole there. So now it's 0 again, and then they can add it again onto the A. They can add it again to the furnace. Like this. So now it's became 0 again. And every time a new heat starts, it's counted up, and then they can track the consumption or the use of that pole. So to go further down, they can enter the materials they have fed into the furnace, the resources they have used, electricity, oxygen, and natural gas. All of these are coming automatically from Historian. If we then go to the refining stage, which is called ladle furnace here, they can see again some important information about the electrical furnace, the base material that was used, and some of the refined materials that they already put into the furnace. We also have some important KPIs here, which are not shown right now because it's a bit of an old heat. But if we go, for example, to a new one, there are some important KPIs are shown for the next stage. Because it's important to keep a steady supply to the casting area. Go again to our example. The steel analysis. Here we can see the quality defects that have been added by the people at the melting stage, and we can also see the comments they have entered here, so that there was a new low carbon of DRI. The steel analysis occurs every time they add refining materials to the ladle. The values here shown in red are out of specification, which can be configured in the plant apps administrator. Then the next part is the continuous caster. On the left, we see again some important information derived from the melting stage and the refining stage. And on the right, we see information about the casting stage. The tonnage temperatures, if they become too high, it means that the refractory materials will need to be replaced. And these targets are again configurable in plant. So right now, everything is fine. But if we say, for example, that this temperature exceeds 400, it will turn red. So they know, okay, we need to replace the tonnage. We can add quality defects again here. Check the steel analysis, enter information about the strands, where the billets come out, and enter a comment if they need to. When the billets have been produced, we can move them either here right now it's set to be direct charging to the rolling mill yard, but we can also say, no, it's going to our own yard, to CC5 yard. And then we can assign a location to it. So you can say, okay, I want to move that charge, that heat, the 51 billets that have been produced. I want to move them to, let's say, E07. Okay, I add them. And then I can go to the yard map. And I can see, I can search for the E07. And I can see here that I have added the 51 billets here right now. So in total, we can also search for certain quality on this yard. So we can say, okay, I want to see where all my where the quality, where this type of quality lies, or this type of quality. Or you can say, okay, right now I need this quality to be moved to a different location in the plant. Okay, then we say I'm gonna move 51 of those, and I can move them to the RM yard like that. Right. Then the final piece, as I was talking about, is a dashboard for the supervisors. Here they can see some information of the past 24 hours, how many heats have been produced, and how many of those were with the quality QB44 or QB46, 7 days as well. See some averages, tap-to-tap time, electricity, oxygen, etc. They can also see some information regarding other areas in the plant. So they can know what's being produced right now and what the quality is. So that was it from my part. And then I give back my word to Stuart.
Right, thank you, Leonard. That was really interesting. So we saw, within the short demo, we saw heat details being shown. We saw quality defects being managed. We saw a composition of the final product. We saw the analysis of the steel, electrode management, tonnage management, concast, and of course the yard and dashboard. So covered many use cases in a short demo. So that's great. So the next part of today is to talk to Pradeep from Qatar Steel, and really just get his view on how the real project recently deployed went. So we have some information regarding Qatar Steel and the bio of Pradeep in this slide deck, and we'll really be talking about the recent project. So hello, Pradeep. Thank you for joining. Hopefully you can hear us okay. So could you start maybe by giving us a brief introduction on Qatar Steel and the project that was executed? You're on mute. Sorry, you're on mute, Pradeep.
Okay.
Okay.
Thank you. Thank you for inviting me to this session. It's a pleasure to be a part of this MES webinar. So let me start giving an overview of what Qatar Steel is and what kind of production units we have and what are the different products we handle here. And then we will later on jump to the MES part, sharing how it has been implemented. So Qatar Steel is one of the leading steel producer in the Middle East. In fact, it is the first integrated steel plant in this region back in 1974. And we have been supporting major infrastructure and construction projects across Qatar and in the Gulf region. Our plant is fully integrated with 4 production units working seamlessly together. The first one happens to be the direct reduction plant, where we convert the iron ore into solid iron, which is also called as DRI. The second is the electric arc furnace, where we melt the steel with a combination of DRI and scrap. And the third one is the continuous casting plant, where we cast the molten steel into billets. And finally, we convert the billets into the finished product in the rolling mill unit. So our core products are DRI, HBI, and steel billets, which are the semi-finished products, which is used in various applications. Our main finished product is reinforcing bars or rebars, which comes in different sizes and diameters. So they are specifically tailored to meet the construction industry requirement. So we also operate a well equipped jetty facility. It handles the import of raw materials and the export of finished product. And it is basically supporting our logistic and supply chain. So let me talk about the MES implementation. So I have to take you back to 2003, where a company implemented ERP system. So it was a significant milestone for us, where we were digitizing the enterprise functions such as the procurement, finance, HR, and manufacturing. However, our manufacturing module was not connected with the level 2 system from the shop floor. And due to this, all our production data across the production process was manually recorded first in a paper or in an Excel sheet. And someone at the end of the day or end of the shift would enter this into the ERP. So this led to a number of issues. Basically, the first would be the human errors. There could be a typo, there could be a missed entry or incorrect values that has been entered into the ERP, which caused some more problems, such as the inventory mismatch, and there will be a delay in reporting. And we also face challenge while doing the audit and meeting certain compliance. So in order to mitigate this issue, a company decided to implement MES. So our goal was very clear that we would use the MES to connect with the level 2 to fetch the production data, the real-time data, without interfering with the existing automation system. And then we would create a central data repository within the MES and use this data to update the ERP automatically. So with this, we will be able to have a real-time visibility into the inventory, and this will also eliminate the manual entry. And more importantly, we will be moving away from paper and we'll be going digital with this approach. So over the years, MES has helped us to reduce the manual errors, and it has improved our traceability. And also it has helped in getting a faster response on the shop floor. And for over a decade, MES has been running fine, and we have taken the next step, where we are upgrading from a desktop-based to a web-based MES platform. And we are also implementing high availability to ensure we get a better system uptime. And we are also extending our MES coverage to include ladle management system and the product delivery, which these are the two critical areas from the operational reliability point of view. So that is what our journey has been. And right now, as we speak, we are upgrading our systems, and within the next 1 month, we will be completing the upgradation project.
Very interesting. Very interesting. So how do you feel MES has improved the production process? You know, is that maybe utilization or visibility or traceability?
Yes, MES has brought a shift to way how we manage and monitor the production processes. And one of the significant benefit is with the help of dashboards and KPIs, we can see the real inventory status, because it will give you an instant insights into what is happening on the shop floor. For example, we can today now closely monitor the composition of the basket, and also we can get to know what is the raw material that has been getting used, and the operators can access the quality parameters at every production process. And in terms of traceability, the MES has enabled full material genealogy. With that said, if you are able to find a serial number for the finished product, you can track it back to the heat to understand what exactly raw materials were used, and you can also understand the exact process conditions it has went through. So I believe that it has brought a significant value in terms of how you can better control your quality, and while also enhancing the overall accountability and responsiveness when it comes to the shop floor.
Right. Well, it's been really interesting. So, thank you for those responses, Shant. I think we now want to just move on and see if there's any questions from the audience.
Yep.
For myself, for Leonard, or for of course for you, Prashant. So,
Thank you.
Yeah, thank you very much for this presentation. Thank you, Stuart, Leonard, and thank you very much for your participation. It's always very insightful and valuable to hear the perspective of a customer. So we have received a couple of questions, and you can continue to ask the questions in the chat. You can also reach out to our colleague Cataldo. You have the email on the screen to see if you want to ask your question on the side, and he will share the question with the best expert who can answer it. So the first question we had: how much of what was shown in the demo is custom coding? How much is configurable OOTB?
Okay, Leonard, I'll probably ask you to answer this. As I understand, there's a lot of templating done.
Yeah. So the backend is fully configurable because it's all in PlantApps. It's all using the standard models. It's all using standard modules of PlantApps. As you saw, for example, the operator cockpit, that's a bit of custom coding, but also there, most of the things there is configurable in PlantApp. So let's say, for example, you want to have a different product, then it's automatically there, or you want to have a new variable appear on the screen, you just enter it there. Sometimes, of course, you need to do some additional coding, but that's very less, not that much. So most of the things is configurable in PlantApps.
Okay, thank you. Next question. Where is the planning of the heats be yet done / be yet done?
Maybe you can answer that because it's in ERP. The planning of the heats. So the planning of the heats, I think it's mostly done on a high level in ERP.
On the ERP, yes. Yeah. And then that with the help of ERP views, we get that information into the MES.
Yeah.
That is how we do it here.
And then there is a planner who has access to an application here on the MES to plan it even furthermore in detail. And then the operator himself, he can see what's coming, what he needs to produce, and how much is left. But his view is quite limited.
Yeah, and I'll just add to that of course GE Vernova have recently added finite capacity scheduling to our portfolio, so this may be something to look at in the future.
So we are at time, but we have a couple more questions. So one question is about if you will receive the video, the replay of this webinar. So you will receive it by email, and you can access it also through the QR code that we show at the beginning. I'm sharing in the chat to answer a question on can the template apply to other metals industry other than steel and also other parts of the process. So I'm sharing a webinar that we've done on rolled products, for example, to give you an example. And then quickly, how was the integration realized between shop floor and ERP in terms of inventory and production process, especially for NC handling?
So,
Where exactly the question here? This question. I think we just have views on the ERP system, and then
Integration realized between shop floor and ERP.
so we get a
As I said, we get an ERP views which will help us understand what is the inventory, the on-hand stock from the ERP, and that's how we understand which lots to use, and that we show it to the operators, and then they use it according to the physical raw material that is available on the plant.
And if they then produce something like, for example, as shown in the example, the billets, then it gets sent back to ERP, also to some kind of view.
Yes.
Some kind of view. It's sent back to ERP.
So lots of questions about the ERP. If you don't mind, we'll continue. So when MES communicate to ERP, when does MES communicate to ERP? Every minute, every hour? And how is integration working when system having updates?
Okay, so in the plant application, we have models which we can set to run every 2 minutes or 1 minute as the minimum. And we can set it to run like every 10 minutes or 15 minutes. But here, what we are doing is based on the plant process, we keep the time with respect to that process itself, maybe around 10 to 15 minutes. And when the system is down, when the ERP is down, what we do is we keep all the data in the MES, and when the system is up, we push all the data back to the ERP. That's how we manage whenever there is a system update. I hope that answers the question.
Yes, thank you. There's also another question, which is a follow-up about integration. Where is the replanning done in ERP as well?
The replanning is done. I think it is done in PMM and in the MES system itself, and it is communicated to the shop floor whenever there is a change. And maybe I think parallelly they will do the change in the ERP as well, because we cannot change the job quantity which has been defined in ERP. So any change with respect to ERP jobs will be done in ERP, but that will be communicated from MES to the shop floors.
And one last question for Lennart. Who is responsible for repairs and maintenance on the automated machines on the floor?
For the MES system, okay.
But still, maybe that's more a question for you.
Yeah. We right now we have a resource who understands the application. So to a certain level, he is able to manage or maintain any changes with respect to MES. But if there is a bigger change, then we involve the consultants, or we go back to GE and ask them to do the change.
Great. So I think we have covered all our questions. Thank you very much for your participation. So the participations of the audience, and also you, Stuart, Lennart, and Pradeep, for this presentation and interview. We will share the recording of this session by email, so you can replay it or share it with your colleagues. And feel free to reach out to myself or Cataldo if you have side questions, and we will share it with the experts. So thank you very much, and we hope to see you in the next one. Thank you. Bye.
Thank you.
Bye-bye.